Hi folks, Joseph Kursky here with you to interpolate surfaces and look at real-time data feeds, in this case weather, in ArcGIS Online. Happy to be with you. As you can see here, I've got visibility and transparency settings inside ArcGIS Online. I've got a variety of data at my fingertips that I've loaded from the Living Atlas of the World and also from ArcGIS Online itself. NOAA infrared satellite imagery, current temperature, pressure, wind speed, a couple of political boundaries as well that we'll use later on in our interpolation section of this exercise. I can turn on and turn off these layers. I can see that I've got current or near real-time wind, temperature, and pressure. Okay, and I've got pop-ups for each one of those points. Wonderful. What I'm going to do next is I'm going to use styles and change the style. Let's pop up a legend there. Change the style for now I'm going to look at pressure. Okay, so I'm looking at the different pressure. You can see a big pressure gradient here in the USA where you've got light colors as low pressure and dark colors as high pressure as of the time I'm making this. Look, we've got color ramps at our fingertips. We can look at the table of data, and I've done a now filter of the data where I'm only looking at low pressure. So I'm filtering out the total data set. I only see the points where the low pressure is. Now I'm going to add a sketch layer, and I'm going to add low pressure sketches to my map. Those are my hypotheses of where the low pressure is. I've got a couple of low pressures around Iceland. I'm going to ignore those because I don't think they're significant here. Now I'm going to take a look at, is there significant precipitation near the low pressure systems? There should be. Interesting. What about wind speed? I'm going to symbolize my wind speed, and similarly, I'm going to bump up the size of those wind pieces, and now I'm going to add to my sketch, and I'm going to say windy. I'm going to symbolize the text in a bluish tone. Windy is there because I see a lot of high wind speeds there. I'm going to click on a couple of other places where there's high winds. You see where I'm going with this, right? Simple but powerful tools to teach about content, in this case meteorology, using GIS. So the students are gaining some GIS skills, but they're also learning about pressure systems and predicting the weather, which is actually a part of this unit. So now I'm going to take a look at a different variable here, and let's just extend our analysis a bit more. Dew point temperature difference. What did I do here? I created a temperature minus the dew point. If it's less than 4, now these temperatures are actually in Fahrenheit, so it's good to know about your units. If the dew point temperature is very close to the actual temperature, the air could get saturated and you could have precipitation. So this is part of my weather prediction part of the lesson, if you know what I mean. Don't get too scared by this. This is just a little piece of Python inside ArcGIS Online, and it's called the Arcade Scripting Language. Very powerful and simple and easy to use. So now, once I've symbolized based on that expression, I know where the points are, weather stations, where the dew point is very close to the actual temperature. So I'm going to predict that it's going to be potentially rainy there or some sort of precipitation there very soon. Interesting, interesting. And now I'm going to symbolize those points red and blue, and the blue is where the criteria was true. In other words, the saturation expression evaluated to true. In other words, the actual temperature is within 4 degrees F of the dew point temperature. Interesting. And now I'm looking at my radar precipitation and also my cloud from my satellite imagery to see if, okay, it makes sense. The places where it evaluated to true is in cloudy and actively precipitating areas. So my prediction, my hypothesis bore out. Interesting to be able to do this with these data sets. You know, I had a lesson for years that I used static weather readings for, I think I had 2017, the year 2017, and I'd have students evaluate weather for 2017. And as the ArcGIS Online system with real-time data feeds matured, I said to myself, you know, I could do this for real-time data. Wouldn't it be much more interesting? And I predict the weather from now until maybe 72 hours from now. Interesting. And notice here you also have at your fingertips hurricanes, looking at hurricane tracks. Right now it's winter in the northern hemisphere, so I see, as I hypothesized, a couple of southern hemisphere cyclones. but I've got that at my fingertips as well. So think outside the box here. You've got a lot of other real-time data feeds. Now I'm going to go ahead and turn on some polygons here because I'm going to use those polygons as sort of a cookie cutters or muffin tins, if you will. I'm going to clip out certain weather stations and I'm going to predict a surface. So now I'm going to filter where the state name is California. That's the state I'm going to choose. You could choose countries. We'll talk about that in a moment. Here I'm going to pick a state in the USA, California, and that's what I'm going to use to create a prediction surface. A prediction surface. We've all seen those, and I want to empower students with creating their own prediction surface or interpolated surface from points. Now this could be elevations from from several elevation points. It could be a crime surface from crime points. But here it's temperature or pressure or wind speed we could even do. I'm using temperature right here, and I'm using my powers of observation right now. I'm seeing that, okay, in the northwest part of the state, you've got low temperatures at this time because it's real-time data as of mid-March 2025. And in the southern part of the state, Mojave Desert, I've got some higher temperatures. Interesting. So my prediction is that my interpolated surface is going to show exactly that, low in the northwest and high in the southwest. Interesting. So I'm going to look at air temperature input layers for my interpolation points tool. Okay, so I've got the input as the temperature layer. The cookie cutter layer is my state of California, right? It's my selected piece of the polygon layer for states, if that makes sense. Again, you can't use a base map, even though it has state and national outlines. You can't use that for your surface. You've got to use a polygon. So in this case, I've run the tool, and now I see that, okay, I've got my filter on just for California, and I'm looking at the temperatures, again, thinking about what's that interpolated surface going to look like. I've added some labels here. I've also rounded the labels just to 1 decimal place, which is useful in this case. You can see me rounding here. It's just another arcade expression so that I don't get a huge string with 10 significant digits when I don't need 10. It's going to clutter up the map and obscure what I want people to see, and that is the actual current temperature. Okay, now I've created that surface using the Interpolate Surface tool inside ArcGIS Online. And as predicted, I see a gradation from the northwest part of California to the southwest part. And I've also labeled the surface with a low and a high for that particular zone, as you can see here. That's why I've got a range in here, 45.5 to 48.7, 39.4 to 45.5, etc. So my prediction was correct. My surface now is an interpolated surface. It looks at the values and interpolates the surface. Here's my expression. I'm going to round both of those low and high values. That's just for the label, just so you know what I'm doing there. Value min and value max. Interesting. Now, what do I have? I've got an interpolated surface. Again, think outside the box. You could interpolate crime, pH in soils, etc. But also on the data quality side, think about the following. You've got weather stations for all over the world. If I interpolated a surface for Algeria, most of the weather stations are actually up in the north central part of the country. There's not very many in the Sahara Desert, in the south and southwest part. So your interpolated surface will work inside your GIS. All you need is a country outline, which is available in ArcGIS Online, Living Atlas of the World. So you can predict the surface there for temperature, pressure, or wind speed. But how confident are you going to be? So I want students and others to understand data quality issues. Just because your GIS does something, can you trust the results? It may be useful for an interpolated weather surface in Algeria, especially for the northern part of the country. But for the southern part, you would be very wise to be cautious about when you're interpolating a surface and you have very few points. In the case here in Northern California, notice it's not using the temperatures in Nevada and Oregon. So I have less confidence in that northwest part being accurate. If I wanted more confidence, I would actually use the Nevada and Oregon points as I'm interpolating that weather surface, if that makes sense. Now I'm using the elevations base map and looking at, okay, temperatures as I'm labeling the features, higher elevations, mountain valleys, etc. So it makes sense that these temperatures are lower. What's the influence of coastal areas on temperature? Oceans have a moderating effect, so they should be cooler in summer and a little bit warmer in winter than the interior of the state or a national situation. So I'm looking at different temperatures and looking at the elevation, proximity to coastlines, the season of the year, what the weather is like, high and low pressure systems, and so on. Interesting that you've got all these tools at your fingertips and all this data at your fingertips, and you can teach about content, in this case meteorology, elevation, coastal influences, etc. But you can also teach GIS skills like interpolating surfaces. So that's what I love about teaching with GIS. You're teaching content, you're teaching skills, and you're also teaching the geographic perspective and the holistic perspective, that these are all connected. The physical, the natural environment, the human influenced environment, they're all impacting, and they're all important here. So fascinating looking at the temperature gradations right now. You got 98F in El Salvador, and up in northern Canada you have less than a third of that. So looking at the Sahara Desert right now, what time of day am I actually panning across here? It's not mid-afternoon in the other side of the world, so that's a factor as well. It's just great that you've got real-time data feeds, weather, earthquakes, stream flow, hurricanes, and much more at your fingertips. Thanks for being with me. Map on.